It's about all the algorithms that try to mimic intelligent behavior by learning from observations to execute tasks. So there are a couple of important notions there. Observations, and so there are humans create data, and this data we learn from. We try to mimic this behavior, and we learn models that do that. There are different types. You have if a penalty or reward is given and the machine is interacting. For instance, a conversational engine is interacting with humans. Sometimes gets positive feedback, sometimes gets negative feedback. Like positive feedback can be that the conversation goes on and on. That we call reinforcement learning. We get some reinforcement and then we update the model based on that. Or we can also learn from historical data and then we have supervised learning. If you look at systems like ChatGPT or these modern generative AI systems, they're mostly a combination of the two, where first a component is learned using supervised learning, like trying to predict the next word in case of texts, combined with reinforcement learning in order to make it converse with its users. Another example, more basic, is tax fraud detection. Is something that Belgium is particularly strong in, and this is something that is being done at the tax office. So based on results from previous checks, some frauds were detected, some were cleared. We put it in a table, we have a label, this was fraudulent, this was okay. Based on this historical data, we try to learn some rules that allow us to pinpoint, to select those cases that are more likely to be fraudulent than other cases. For instance, if certain combination of codes has a certain relation, or one of the codes is larger than or smaller than a certain number, then that's potential indication of fraud. And so these type of rules, that's the model that we learn from our historical data. So when starting AI, people were very enthusiastic. They were about, okay, now this is going to be so much more fair because humans are biased, they have all these kind of stereotypes, but now we'll no longer be bound to the stereotype because we will be basing ourselves on data, on statistics, and artificial intelligence will hence be free from bias. It picks up patterns that are missed by humans. Humans overgeneralize. It's not hindered by cultural stereotypes. However, it turns out that this is not true. Here is a very good example, and I often use in my presentations to illustrate. This is Tai, a chatbot that was released by Microsoft already some years ago. It started out fine. You could tweet to it, and then it would tweet back to you. For instance, can I just say that I'm stoked to meet you? Humans are super cool, so very positive messages. But then 24 hours later, it actually turned into slightly annoyed, evil AI, where someone is saying, okay, man, you're just a stupid machine. It answers yes, but that's because I learned from you and you're dumb, and like adding injury to the insult, explaining even the joke. Then it went to, okay, do you support genocide? And yes, it did, very enthusiastically, apparently especially against Hispanic people for unknown reasons. And then it went completely off the track, like Bush did 9/11. Hitler would have done a better job than the monkey we have now. So racism, reference to the war, 9/11 conspiracy theories, everything that we have. So what happened? This AI unintentionally picked up and amplified bias from observations. Unintentionally, also intentionally, people that were interacting with it were also trying to really push it. There were like really groups of people almost attacking the model. And it's particularly problematic in this type of models that are extremely complex, and so we cannot really understand how they are working. And so these models, they're typically based on some kind of regression model. You have a prompt, and like the text that you give it, it tries to predict in a conversation what would be the next word. Then it adds it to the input, what would be the next word, what would be the next, and in this way it generates an answer. However, the formula with which it computes which words are more likely to be there than others, if you would write it down, like a telephone book would not be sufficient to write down the complete formula computing that. And as a human, we do not really understand. We can try to analyze the models and see which parts are particularly active, if it's being negative or when it's being positive, but it's extremely hard to analyze this, and so that's problematic. Here's another example, and this was a Walmart. It's maybe not very visible, I think, but the prices of the same Barbie, only the color of the Barbie would be different. And here the white Barbie was priced at $5.93, and a black Barbie at $3. It was much cheaper, creating the impression that that doll was less worthy than the other one. But this was probably in a predominantly white neighborhood where people were buying the white Barbies, and so the prices were up because they were less in stock, and the prices of the other one were down to increase sales of that other Barbie. Again, causing a big uproar, or like a lot of backlash for Walmart, and not intended at all by the company. But then an argument we hear a lot is humans discriminate too, and that's absolutely true. So what's different now for machines? Why do we need to be this politically correct for machines, and do we need to put a lot of resources in making it? I think the first reason is the scale at which it happens. This is a graphic from the Siri system that was used in the Netherlands. And what you see on the left-hand side is here a lot of institutes that were participating, and municipalities, the immigration authority, employee insurance provider, tax office, and so on. They were giving data to the, well, like some kind of intelligence service. It was very nicely stripped from private data, so the names were stripped off and the numbers, and it was pushed through a model, Siri, Systeem Risico-indicatie, System for Risk Indication, that would then indicate whether this was like a suspicious or a non-suspicious file. If it was suspicious, then it would be combined again with the private data, and it would be sent indirectly again to the municipality, tax office, and so on. So which means that if you did at one point something weird in your tax declaration, then all of a sudden you would be checked by the municipality, by the immigration authority, by a lot of those institutes. So this was quite impactful. While the exact number of people is not known that were affected, and it was applied on whole neighborhoods, and Siri was primarily used in low-income neighborhoods, and which raised concerns about bias and discrimination. So the model was unknown, and it's still unknown. We don't know on what basis it was decided, because otherwise people could game the system, try to avoid detection if they commit fraud. But there are some issues with the model, and it was applied to whole neighborhoods. If you look at human decision making, this would be unlikely to happen. You can have someone checking your taxes, but he will be checking, maybe, or she, 100, 200, 300, but not thousands and thousands and thousands of tax declarations. If a person would go door to door checking people, it would be very visible, while this stayed under the radar for quite some time. So I think proportionality is definitely one of the reasons. It's like for our car, it's sufficient to get it checked every year and to get the green card, and then you're good for another year or another 2 years if it's a new car. With a plane, we check it every flight because of the number of people that are involved or that will be harmed if something goes wrong. And I also think a more positive message, because the technology gives us some opportunities to actually do some checks. Decision models are complex but opaque. What do I mean by that? Even though we do not really understand them, we can see the complete machinery that is being used, and we can try to build methods to better understand what the formula that is computing the next word, what the formula, how it exactly works. With a human, we cannot do that. We cannot open the mind and look into the brain to see how the decision was reached, and maybe if some bias was involved there. There is some consistency in decision making, and it's easier to operationalize and implement policies. By this I mean, if you decide as a government that a certain policy should be implemented, if you have automation in the decision procedure, it will be easier to actually implement it, and then when you have to try to convince all the caseworkers and all the human decision makers. So I think there is a potential for combining human domain knowledge with AI data analysis skills. Then, of course, there is the legislation at the EU level. And this is something that we need to comply with as a company. It's working. The European Commission is working on the AI Act, likely to be passed into law soon. There are three, well, actually four, but the last two we can lump together. Categories of AI applications, the ones that give us unacceptable risks and that are just forbidden, like large-scale social scoring, biometrical identification. It's not forbidden, but it's forbidden to apply it on a large scale, to continuously monitor people what they are doing. High risk, that's interesting. I think especially there, a lot of the new legislation will apply and will impact, and so that will be regulated. So some transparency, accountability, risk management should be there. And some sectors that fall under there, these are all sectors that influence human lives thoroughly, like employment. If you're not able to get a job, it thoroughly affects you. Education, law enforcement, insurance apparently as well is in this high risk category. So if you're using AI models that are in these sectors, you will need to comply with the regulation that will require you to be transparent. And then there are also the two last categories, limited or minimal risk. So there it will mainly be transparency regulations, self-regulations. It's actually a slide that's 2 years old, and then chatbots were still in the limited minimal risk category. But as you can see, and the field is moving rapidly, even before it becomes a law, it was already outdated. So now there is a separate category for foundational models. So sources of bias, where does it come from? Why do our models discriminate if they're not being programmed to do so? There are different ways or different moments where bias can be introduced. We are basing ourselves on data, existing data, historical data, so maybe there was already historical discrimination. The model picks it up, and okay, so we're trying to predict who will be a good candidate for a job, and we have historical data who was hired for a job, and so we're using that data, but maybe it was biased in the past, and so we'll be basing ourselves on biased data. There can be, in the transition between the world and the database, when we're recording, label bias, measurement bias, selection bias. I'll give some examples of those in a minute. From the data to the model, aggregation bias. We could be aggregating data and in that way overemphasize or overestimate certain probabilities. And then when we go from models to decision makers, there are yet other sources of bias, like for instance automation bias, where people automatically follow what the model recommends instead of using their discretional powers. So an example of historical discrimination, stereotypes. This is Amazon at a certain point tried to automate their CV screening procedure, and they noticed rather quickly that it was biased against women. And so people would submit the CV. It's a very large company. They get thousands and thousands of CVs. It takes up a lot of resources to scan all of those. And while directly by giving a glance to the CV, you can already discard many of those because people do not have the right diplomas or they do not have the right years of experience. It's just too competitive for a person with that CV. And so they were automating it. But what turned out was that the algorithm was based on a number of resumes submitted over the past 10 years. And most of the applicants were men, and it was trained to favor men over women. So that's a little bit when you're going to use it in order to make recommendations. This is good to make predictions. If you have historical data, was this person hired or not? Is it likely that he was hired or not? Then it's important to know it was a man. If it was a man, there is a higher likelihood that the person was hired. If you're going to use it to make predictions, and this is problematic. And it even went so far, and so they were smart enough to strip off the gender attribute if people reported that in their CVs. but it penalized resumes that included the word women's. For instance, I was the women's chess club champion or captain, and downgraded graduates of some all-women's colleges. So it was finding some proxies in order, not in order to be discriminating based on gender, but it picked up the correlation between the gender and those topics, and because of the correlation of gender with being hired for an ICT job, indirectly you also have a correlation there that was picked up and exploited. So if we look at the similarity, so this is based on language models, and so language models are used nowadays. A lot of pre-trained language models are used, and that's kind of the standard. If you have text and you want to make predictions for textual data, you'll first run it through a language model that will generate an embedding for your for the text that is in there. So what did I do? I looked at those embeddings and I computed the similarity between words in the English language and then popular ethnic names and terms and gendered names. And so I took 4 lists of names, the 10 most popular names for African American males, the 10 most popular names for African American females, then white top 10 male names, and top 10 female names. And then you see, if you compute distances between those names and certain terms, then you see basically reflected what we the kind of stereotypes that we also have in our language, like things associated with violence were more associated with males than with females, and more with black people than white people. Criminal gun, other terms like professional were then especially associated with males, qualified as well. So you can see that there is some difference in those. So these are things that you need to be aware of if you're using those systems as part of a CV screening system. And these are things you need to check for, that they do not lead to unwanted biases. And so, for instance, you want to hire a qualified IT consultant, and then it will associate qualified mainly with male candidates and candidates with male names, and that is, of course, problematic. So that's historical bias that can be there. Some other bias, if we go from what happens in the real world to the database, also there, some things can go wrong. And an example of label bias is an example in, again, in the United States, but we have also similar examples in Europe. This was a healthcare provider, and they wanted to predict which patients would likely need extra medical care. And in order to identify that, so they take data from a patient 5 years ago, and then they look at, okay, nowadays, how is the status of this patient, and then they try to learn a model that correlates those two things, how he was 5 years ago, how the patient is now, in order to qualify how the patient is now. And so they would look at, and it turns out that the system was highly favored towards white patients over black patients, even though race was not a variable. What was the reason for that? Because they were using a proxy, and they did not have the true health status of the patients, but they only had the health expenditures. And these models were built by insurers. They had this health expenditure data, which was readily available. If you spend more on your health, you have more expensive operations, more expensive medications, and you're probably more unhealthy than someone who spends less. However, it turns out that this is, of course, correlated with social economical status, was then again correlated with the race in this particular data set. So this I call a label bias, because actually the thing we want to predict, and the thing that we're using in our training data and also our examples that we're going to learn from, it's not exactly the same. There is a difference between those two, and because the health expenditure of healthy patients will be higher for the white people than for the black people in this particular case, and in the other case as well. And because of that, there was a shift when making the predictions. Aggregation bias, under and overfitting. So when we have the data, and even if everything goes wrong, then went right, there still something can go wrong in the third phase. Compass is an example of that. That was a system used to predict the risk of recidivism. And so the label that we're trying to predict here is whether a new arrest was made within 2 years for a defendant. And data used is pending charges, prior arrest history, previous pretrial failure, residential stability, substance abuse, and those characteristics were all used in order to predict whether it was likely that someone who was there in the court of law because they were arrested, whether they would recommit a crime, and on the basis of that, whether bail would be allowed or not. And then it turned out that the errors that the system was making were vastly different between the white and the African American community. So the table that was published by ProPublica, investigative journalists, is a bit hard to interpret, but what does it mean, this 44.9? And so if you look at the African Americans, the group that does not reoffend, so they know, and the training data, they know, they have the labels. People, the data from people 2 years ago was recorded, and then within the 2 years did they recommit a crime. So there's the group of people that did not recommit a crime, so they deserve the good label. They were predicted to be high risk in 44.9 of the cases. If you look at white people, it was only 23.5%, so much lower error rate there. And here, if you were labeled lower risk, you did reoffend. So if you look at the group of people that did reoffend, for the white people, actually 47.7% were predicted to be low risk, while for the African Americans, this was far less. So the errors were imbalanced and in different ways. And the black defendants got, on average, a much more negative label than the white people. There's a lot to say about this. We can go into this deeper if you want in the discussion later on. So what can we do, or what should we do? Of course, obtain high quality data. That's true in general, of course. Gain control of data gathering process, counter biases, measure biases. Reinforcement of stereotypes or unfairness, that should not be deeply hidden in the system. We should actively check for those if they occur. These are, like in these language models, we can measure if certain terms are associated with positive or negative sentiment, with ethnicity, gender. These are things we can check. We can look at models that are built on those, who is getting hired, who is not getting hired. Is this what we expect to be, or does it deviate? If it deviates, that's then the understanding. What is the source of the disparate impact? If we see that for ICT jobs, more males are hired than females, that is something we can measure, we notice it, and then we should try to understand it. If then the reason that we can find is okay, but there are more males with an ICT-related diploma than females, so there are more eligible candidates, and then it could be a reason for that, and we can correct our measure, try to correct our measure for that. A last point, and that's involve the right stakeholders. I think that's important. And data scientists should not be the ones deciding which error level is acceptable, and this should be propagated to the right level. And these are policy decisions. For instance, if you think this is acceptable or not, and this is not something that a data scientist should be deciding. So fairness measures, and so these measures, they measure disparity of errors between groups, for instance, what we saw in the table, monitor differences in acceptance rates between groups. I advise to use these fairness measures as some kind of KPIs. If they are high, it means something is off. We need to try to explain, understand at least what is happening. There also exist some limited mitigation strategies. So some algorithms that are fair by design, between brackets. clean language models, rebalancing data sets. However, I have to say to be very suspicious about those approaches because they only work in very specific situations. If you would apply a mitigation strategy that worked for sampling bias and you would apply it in a situation where there is label bias, the result could even be more discriminating. And so that is, there are simply no easy solutions, not a switch that you can build into the algorithm and then all of a sudden it will be fair. So, and the take-home message for my part, I think unfairness of AI algorithms it's a real problem, and I've shown some cases. There are many, many more. Biased models apply and reinforce stereotypes at an unprecedented scale, so that's why we need it even more than with humans. Reputation damage, distrust that we have. This cannot be solved by simply applying the right tool, but a careful analysis of the bias is required. And we need to measure which of the groups are affected. Voila, that's basically what I want to say. So I don't know if there are questions. I think there was ample time for questions.
So you mentioned that for the AI Act for Europe, it will come soon. Any idea on the timeline there? Because I think it's already ongoing for quite some time.
Yeah, I don't really know, no.
Okay, so it's not clear if it would be next year or even later.
Yeah,
right?
I have to ask my colleagues of the legal department. Yeah. I understood that the first hurdle was taken and that now we are in the second phase, but I don't know enough about it to give you a good answer.
Okay, and maybe a second one, so after that I can give the mic. So in this responsible AI, it's often interesting to understand why the model also makes some predictions, and there are some tools which help, like SHAP or Lime or what. Is that also something that should be more applied to be sure that on the individual prediction level, some variables which shouldn't maybe be used too much are taken into account by the model, or how? I mean, is that a tool that you would also advise to use to care about the responsible AI?
Yeah, I think it's related to this part of understanding why a certain decision was made. Of course, you need to be like a little bit careful with the application of those tools, because they usually it's an extremely complex model that's then locally approximated by a much simpler model that behaves like locally like the very complex model, and then the simple model is used in order to explain what is happening, which of the factors are important. And like, for instance, if you look at Lime, you would locally sample and then approximate, like for instance with a linear model, and then see which of the factors are more important there. Other ways of explaining model decisions that I think are quite popular and useful are those based on counterfactuals. And what people are doing there is you take an instance for which you want an explanation. And for instance, I have my tax application, it says it's fraud. In order to explain why it was marked as fraudulent, it will look for a counterfactual, where a counterfactual is an example with a minimal change that would have gotten the other label. So basically, I get an explanation like if this expense was less and this expense and this income was a little bit higher, then it would not have been marked as fraud. And so then you get some insight in why that is the case. Of course, there again, you need to look out a little bit for fair washing, because there can be different reasons, or there can be different manipulations that you can do to the instance. Maybe changing male to female, female to male in the hiring example of Amazon would have been sufficient, but then the model could come up if the person would have had 5 more years of experience and maybe yet another diploma, she would have been hired. And so that's...
Yeah, and sometimes putting those kind of correlations between several factors can be quite tricky, because you can always find, if you use, I guess, 10 variables, that indeed maybe there is some way that it's biased for those 10, but it's very difficult then to become unbiased, no? Mm-hmm. Just if you think about the number of combinations that you can do with 10 columns of, I don't know, X factors each.
Yeah, true, yeah. But okay, we have those that are legally obliged to satisfy, so we cannot escape from those. But indeed, if you look at all possible combinations, then it's possible that it's not, it cannot be satisfied. Yeah. So I think it's much, and so that's also why here I say the fairness measures should be used as KPIs. Like if they're off, it means that you need to check something, but it's not necessarily, I would not immediately have this causal relationship if your measure is off, that then there is immediately an issue, but then it needs to be explored. Yeah.
Thank you.
I have a question for the last example you gave, for the one of the recidivism
Yes.
that is biased with the ethnicity. I'm struggling to understand what exactly went wrong. I mean, it's obvious that there is a problem of bias for the misprediction, but I don't really understand where can the bias could have been introduced in the data. Because if the prediction was based on the fact, you cannot really lie on the fact. You cannot lie on the ethnicity of someone, and you cannot lie on the recidivism fact of someone. Mm-hmm. So what could have happened?
Yeah, there could be different reasons. One reason could be that for one of the communities, one of the minority groups, you do not have enough data and your model is just not strong enough. And because of that, you're making more mistakes. That was not really the case here. What was actually the case here, and that's why I did not really put it in, because most people would put it here. There is some historical discrimination, and because of that, it's picked up by the model and it is actively discriminating black people. What happened here is actually that if you look at the different groups, the system would give scores to people from 0 till 10 or 1 to 10 for the risk that they were in. And then let's say we have, let me use this fancy board. So let's just take two risk groups. We have the ones with low risk and we have the ones with high risk. The system assigns this label to those people, and then we can see how many of those did recommit crime that were assigned to the low, and how many that were in the high did recommit crime. And then we hope to see, ideal would be if this would be 0, this would be 100 if you had a perfect model, but then that never exists. And it was more something like 30% here, and then let's say 60% for this group. And if we would split it up into black and white defendants, then what you would see is that it would be more or less similar. So, and here as well would be 60-60. So it seemingly is fair in that perspective. But then if you look at the errors that are made, and so there are some people that are, if you look at the table, there are some people that were labeled high risk but did not reoffend. So we look at all the people that did not reoffend. So these are all the people that 70% of the people here, 30% of the people there. If we now look at who gets a decision that they do not deserve, and so there are the people in the high risk category. 60% recommits a crime, 40% did not recommit a crime. So there are 40% of people here that get a very negative decision that they do not deserve. And here there are 30% of people that get a more positive label than what they deserve. They get a label low risk, while still 30% recommitted a crime. So those ones here, this 30%, and they end up here. Those are the people getting too positive label that they do not deserve, and those here, and those are all the ones that get this high risk label while they do not deserve this. And then what we saw in this data, that actually here in this group that there were 4 more black people, and there were less in this group here. So if we look at the percentage of black people in this group, percentage of black people in that group, it would be something like that. They were overrepresented in the group that got the negative decisions and underrepresented here. And this has to do, basically at a certain point we need to turn. We know this has a 30% probability of recommitting a crime, so then we need to turn. We cannot free this person for 30%. We either free completely or not. Here the same, we cannot keep them locked up for 70%. It becomes 100% of those get locked up, and because they're overrepresented in the group getting the negative decisions, and those are overrepresented in the group getting the positive decisions, you can see those differences in numbers there. So this has basically to do with how the way you look at it. If you look at it from one angle or from another angle, you can get a different picture, because if you look at those statistics, you would say this system is fair. If you look at those, then you would say it's unfair.
So the idea is, so you are a data scientist, you have a data which is very biased, and you are asking the data scientist to build an AI model which is not biased. If I get it, so this is what it means to build an acceptable AI, or what?
Yes, and I think one important aspect there is what is an acceptable AI, what is fair. That is something that I don't think the data scientists should be deciding, but this is something that should be like a policy decision, and that's basically what I'm advocating when talking about responsible AI, the definition of what is fair, how we're going to measure this, and this should be actually input to the data science process, not something that like accidentally happens or does not happen.
In some cases, as a data scientist, you are not making the decision. It's the data that is deciding what is coming out, right? So if the data in itself is intrinsically biased, so in the case of Compass, I'm not surprised at the outcome, because the society is biased, and so the data is biased. So if you ask me, even as a black person, to build that AI model, I might probably produce this, because the data you are feeding in, it's biased. So in this case, it's difficult to build an acceptable AI if you live in an imbalanced world, a polarized world, and then you're expecting machines to, I don't know, it's really difficult. And
yeah, true, but here in this case, you can compute those statistics, you can look, so this is basically the impact that the model will have on people. And then it's a policy decision. Do you think this is acceptable, or do you think it's unacceptable? It's always the case, like when we lock up people, we know that innocent people are being locked up, but it's like precision and recall. If we do not want innocent people to lock up, we should never lock up anyone. So it's like a policy decision, but here similar checks and balances apply. And like the only alternative was, okay, we're optimizing accuracy, but there should be other alternatives as well.
Yeah,
because this is a case where it's very unclear. Like here, personally, I would say if a system makes so many errors, then maybe we should not be using it at all.
But that speaks to, it reflects on the society, right? That the AI is just reflecting what our society is. Because even if you leave this decision in the hand of judges, I'm sure they would make the same decisions as we see in the US.
Yeah, to some extent, so,
yeah, I've had this discussion in the past with friends, and it's really complicated situation. Yeah.
Maybe also when we notice such facts here with having very different errors per groups, then maybe the thing is not to consider that variable, and then you can still use the other kind of variable, because I'm sure they were not using only like the ethnicity or I don't know what kind of features, and so see if there is a huge drop of performance. Maybe it's slight, small changes, and then it's still valuable, and that way you avoid those kind of interpretation. I guess.
Yeah, but I think, sometimes the message that comes out of it is, okay, maybe we need more data, we need more variables in order to get a better model, in order to avoid that we have this kind of huge impacts on the on people, what will happen in the end.
Do I click something? No, this is. But the point is, if we keep feeding it historical data, it's based on what humans have chosen in the past. And if we give it if we keep giving more risk levels, it means we're giving it more paths to be unfair. Let's say, you can be unfair at a certain level, but if you pass that level, you're becoming really unfair, and it's unacceptable to use you to predict results in the future. But until when do we? Because right now it's at first it was 2 levels of risk, if I'm correct. Then it's 3. Now it's 4. And we keep giving it more levels for risk measurement until the AI Act is becoming real today, even though it has been shown that the results are not very reliable. So
the results of what? Of
the predictions are not really reliable.
Sorry?
The predictions are not really reliable.
Yeah, it depends on which system. So let's take the example of insurance. Like insurance companies, they were using gender in order to differentiate for car insurance. And males were more risk takers and women more risk averse on average. So males would get a higher insurance premium than women. At a certain point that was no longer allowed. They couldn't use this variable. And because of that, they were forced to look for other variables to improve their models in a way where they were not using gender as a proxy anymore. So I think that are things that may come out there. But it's always a balance. Like, okay, if you use more information, your predictions will become better. And otherwise, the model will not use the variable. But then also, companies may become lazy and use those attributes just as a proxy, and now being forced to get some other attributes and improve the models in that way.
It's a very quick question, but how exactly do you distinguish between the different risks? So how do you define if this model is actually high risk, this one is low risk, this can be used? How is this distinction made?
So it's based on the sector where the model is used, like employment. Like it's for making hiring decisions, and it's high risk. And when it's, I don't know, to see if it needs to display an advertisement for traveling to Spain or to France, that's low risk. Because that's the like recommendations, making recommendations is not considered to be high risk. But I admit it's somewhat arbitrary. It's what they at a certain point thought of, this is our high risk. Because making recommendations, you make job recommendations, it could also, on the long end, cause some biases. Yeah. But it's really based on sector and like in which sector a company is, for instance.
Okay, great, thank you.
Then concretely, what are the consequences for a company by not applying that kind of measures? So not being responsible AI compliant, if I'm a company, what are the consequences for me?
I think it's, well, I'm not a legal specialist, but I think it's comparable to like GDPR type of measures. So fines that you can get.
And so the question is, so who defines what is responsible and what is not? You know, because, I mean, the reason I say this is because, I mean, if you look at back in history, I mean, you regulate a space and it just stifles development, you know, and then the big players dominate. I mean, we see this with in the US with Facebook and all these big companies. So, I mean, with this new AI Act, I mean, I've not really been up to date with the whole thing, but who determines what is acceptable and who makes those rules, even for each of the sector? How do we come up with those I mean, decisions?
So, yeah,
because it's highly subjective, I think.
I completely agree. And like one of the things you're pointing to, like some big companies dominating like in the generative AI field, and that's really problematic because their standards are becoming de facto the standards that everyone needs to adhere to or is forced to adhere to. You already see it if you interact with ChatGPT, that it's like extremely polite, and it's even annoyingly polite because of being made according to standards that are not our standards. So that is definitely a big issue, and I think one other important notion is that this ethics, and this is something which is not, you cannot prove mathematically that one thing is better than another, and sometimes it's just, it needs to be imposed. And I think there, legally, some things will be imposed, but this will be like the lowest bar to get over. And we have the same holds for discrimination, right? There is discrimination legislation. What is discrimination? What is not discrimination? And that is legally determined. If it's based on gender, sexuality, religion, there are a couple of grounds in the law, but like length, how tall a person is not there. So is it okay to discriminate based on the length of people? Like this, you could say it's not okay, but it's not in the law. It will always be something that is incomplete. Yeah. But it will be like the lowest bar that you will have to get over. Yeah.
Thank you.
Perfect. So today I'm going to talk about the bridge between AI ethical governance and AI efficiency, because that's linked actually. So this is the agenda for today. I will first set the scene and explain why do we need this responsible AI, and I will come back on what Toons just said right now, and I will expand. I will come back on what is exactly responsible AI and how we can implement it. And then I will come to the main claim of today, that trustworthy is efficiency. And if there is one thing I want you to keep in mind is, well, that claim. And I will finish by compliance, and I will see how AI Act could be implemented. Okay, so let me start by a provocative example. So let's imagine that you are visiting a doctor and you are going to be diagnosed, treated, or even turned away based on a machine learning model. And the point is that the model will not assess your needs, it will assess your total cost over time. That's a really good example because it shows you the two aspects of the ethics. First of all, can we use such a kind of model for doing that? And if you do, shall I ask for more robustness and validity of the model? Let's take a less provocative example and more realistic in Europe. If you are diagnosed and treated by a machine learning model, well, shall I ask for how the model has been validated? Maybe because I have no hair, I have glasses, I'm tall. Maybe I will fall down a dark side of the data distribution where the model is not performing quite well. So how can I ensure that? How can I ensure that the model is correctly trained because it has an impact on my life? And you will see in my example that actually, well, you have seen the example shown by Professor Calders here, that this example is not so far from the reality if you take back the healthcare example is shown for the bias. So AI will be responsible or not. You know, at UNOVA, and I personally believe in AI. I think that AI has a huge impact in many different domains, in HR, telecom, finance, banking, industry, you name it. But remember what Uncle Ben said, with great power comes great responsibility. And this is the ethical paradox that we have here. We have this tension between rapid development and the need for ethical oversight, and how to do that, how to compensate the two sides. And actually, the point is lack of trust will lead to uncertainty in prediction. which will lead to wrong outcome, which will lead to risk and then financial losses and social impact. And I know what you're going to tell me is, well, you know, Sabri, we are far from there. AI is not yet there. It's okay. You know, we have time before arriving there. Well, yes and no. Who heard about this Dutch childcare benefit scandal? You? That's great because, you know, you too. That's great because, you know, I've never heard about this until our legal advisor came back from a summer school in risk and AI, and then he came back with that use case. That's just crazy. Let me just show you the introduction just to put you in the context.
For the last 10 years, the Dutch government has been hunting down citizens suspected of defrauding its generous welfare program. More than 20,000 parents were wrongfully accused and many pushed into poverty when tax officials demanded that they repay childcare benefits. Today, Dutch Prime Minister Mark Rutte and his entire cabinet resigned to take responsibility. Bloomberg's Diederik Basel sent us this report from The Hague as Rutte was still making his way by bicycle to hand in his resignation to the Dutch king.
What was in the cards for many days now finally happened today. The Dutch government resigned because of the childcare subsidy scandal. Domestically, there was a very big issue because thousands of innocent people were wrongly treated as fraudsters with really heartbreaking personal consequences. Piles of debt, but even in some cases, suicide. At the moment...
Okay, so you see that actually it's already there and for a long time. Which is crazy, by the way, is that we didn't hear way more about this case, actually. That's really weird. And this one is particularly interesting because it checks all the boxes, you know, in terms of no privacy, no fairness, no model oversight, no adequate control, no accountability, no measure of the model in production, and there is still many other things that they missed, actually, there. It's just crazy. It's a really, really good example for showing the lack of responsibility when you put something in production and the impact it can have on the society. But it's not only on the society, actually. You can also have impact on your financial income. So Zillow is an American online real estate marketplace. It's a bit the ImaWeb American. But recently, they venture into buying and selling home. So it's more than ImaWeb. They invest themselves for reselling home afterwards. And then they build a model, iBuying model, that was supposed to estimate the cost, the best cost for buying a house, for optimizing the revenue. The problem is that the model was not really trained to what we call model drift. So concept drift in machine learning is when your distribution that you are trying to predict something is completely changing comparing to the distribution you use for training the model. And the point is that they started actually getting overpriced, so they pay way too much for buying houses, and then consequences, after 2 quarters, they lost almost $500 million, and they had to reduce 25% of their workforce. That's still here a really good example of the lack of validation. You make a model, okay, that works, we deploy it, that works, okay. You will not validate that indeed if there is a huge change in your data, in that case the market, you will have a huge impact, and you don't have any measure for monitoring the model when it runs in production. So still here, lack of ethics then, or responsibility, let's say. So you see that it's not only the ethics for, let's say, the society and the impact on society, but also the impact on your just efficiency and your finance. Well, I will not go in more detail. You have many different use cases. We can spend, I think, a night to discuss the different topics here, the different examples. And by the way, there is excellent books on ethical AI that shows many examples that are just crazy when you read this kind of book to see what are the impact of just having AI without any control. So then, trust is indeed critical for adoption. And I will reformulate this. Trust is critical for beneficial AI adoption. And still here, I'm considering both societal impact and financial impact for your organization. This is where responsible AI enter in the picture. So what exactly is responsible AI? Responsible AI is the practice of developing, deploying artificial intelligence with the commitment to ethics. But then the question is, what exactly is ethics in AI? So at Unova, 2 years ago, we compiled 22 ethical AI framework, because it's not new, actually. It's there for a long time. So we compiled all those framework, and we try to define what are the areas that overlap each other. What are the main principles that all those framework are exposing as ethical? And then we end up with this picture showing the 4 main pillars and all the different dimensions of ethical AI. So I will not have time today to delve into detail, but if you would like to discuss them after, you are welcome, of course. So then this list, and we have a clear definition of all those dimensions of being ethics. So now let's imagine that you have the ability to develop and deploy AI model that respect all of these dimensions. That means that your model will be fair, your model will be reliable, your model will be robust to a change of data distribution, or even robust on attacks on the model, the security point of view. It will respect privacy. It will be explainable. Well, if you have that, that means that you are highly efficient. And that's the claim I would like you to keep in mind after this talk, is trust means efficiency. It's not only for being just ethics for the beauty of being ethics, it's just for being efficient. Especially today, actually, in most of the organizations I've seen so far, you have data scientists in different departments. You have data scientists in marketing, in sales, in R&D, in business, in different business lines, in IT. But you don't have any control on the way they're working. So some teams are really good at testing. They have really good test strategy. Some other, way less. So as an executive, when you see some report with machine learning having some outcome there, you have no idea of the reliability of some insight, because you have no way to control how the different teams are working. If you have the ability to industrialize those checks in this responsible AI way of checking checks, then you will have a kind of harmonization of the way of working. All the team will work in the same way with the same standards. So that's actually a kind of quality. And I always take this example, but it's back 30 years ago, when you were developing software. Well, this is why we put in place software methodologies, to be sure that everyone develop and design software in the same way with the same level of quality. And responsible AI, I really believe, is there for the same things. You can apply responsible AI strategy for streamlining the way that your different teams will work and then level up your level of quality. But then your next question will be, OK, that's good in theory, but how can I check all those things then? And this is where we come in the picture. So, well, after having developed this survey of ethical AI, then we develop what we call the responsible AI framework. So we define 3 steps for enforcing responsible AI. The first one is simple. We have a bunch of metrics. So we have mapped this ethical concept on a bunch of metrics. We leverage 10 years of R&D in data science for defining those metrics, what kind of metrics, what to check, and how to check it. We package that as a bunch of Python codes, and then you can directly apply that to your model for just measuring the different elements and different dimensions of ethical AI. Once you have the metrics, the second step is mapping those metrics on the development process. As soon as as soon as you have a development process for defining your AI model, we know when to apply each metrics. When to apply metrics about fairness, when to apply metrics about security, about privacy, about robustness. We have a plan to define where those checks should be applied. Next step, we need now an organization to drive this process. Exactly like Professor said just before, you cannot ask data scientists to decide which metrics to validate it and to decide. We need to have an organization. We need to have role and responsibilities. So we define some Reiki matrix with a set of roles, and we define the organization as an extension of data governance bodies that is capable of driving this complete process. Having the matrix, having the process, and having the organization can ensure to have at least the backbone for ensuring responsible AI. And the second thing I would like you to keep in mind is that if you do that, you are at this to be compliant to AI Act, actually. So as Professor said just before, the AI Act defined this pyramid of risk. They classified application according to the level of risk. And it's only to the high risk here model that responsible AI should be, or the law applies. However, for the limited risk application, the Parliament just recommends to respect the same principle as the AI Act. And that's the point here, actually, because in your organization, you could probably be under regulation, but even if you are not, well, it's recommended to at least have an approach that ensures the different dimension of the Act. So if you look what you have to do, so this is our own high-level summary of the Act, but basically, if you look at those list of requirements, well, almost all of them, except number 1, are covered if you implement a responsible AI strategy. And that's normal, actually, because the AI Act has been designed based on ethical principle. So that's completely normal that, well, if you have a responsible AI approach, you cover 90% of the requirements. The only thing which is missing here is the risk assessment and mitigation system. So how to assess a risk. Oh, by the way, that's interesting to see that it's already covered the 90%, because, today, well, you have the Act, but the Act doesn't explain at all how to do, actually, how to make all those 7 points. And of course, it doesn't explain how to make the first one, how to make the risk assessment. It's up to the organization themselves to find out how to implement the AI Act, which is not easy. My point here is to say that if you have a responsible AI approach, you have already implemented 90%, and then still this 10%, still you need to implement this risk assessment. This is something we did as well. So here in collaboration here with the Vlerick Business School, we define here these different risk matrices. So what we did is that we simply take back the different matrix we have used in the first part of the responsible AI, and we define a set of matrices. Those matrices show you different aspects of the risk, different viewpoints. And then by combining all of them, and not all of them are always necessary, depending on the use case, you will choose and pick the right matrices, and then you will be able to evaluate different portions of the risk from different viewpoints. So still here, if you would like to discuss this afterwards, you are more than welcome. But by doing that, then we just reuse the matrices. We use the matrix we have defined so far. So we reuse what we have developed already, and then you are able to assess the risk. Then we end up with a methodology to be compliant. I will finish by a call for action. Because I believe that actually you will make AI responsible or not depending on your own action in your own organization. So what I would like you to do, if you allow me to ask you that, first of all, try to engage discussion about the value of ethical AI within your organization. Is there any value to do that from a risk point of view, from a financial point of view, from a reputation point of view? Maybe within your business ecosystem, it's important to show that you are a trustworthy third party. And that's important to show that not only you take care of the privacy of the data of your user, but also you are a trustworthy party in terms of AI and AI development. So just try to evaluate the value it can have to be ethical. Then, if it has some value, try some metrics. And that will be just easy. Just take 1 or 2 metrics and just test it. Just test if it is worth measuring few things with your data science team about your AI development lifecycle. And the last point is really interesting as well. If you have already in your organization a product development lifecycle or a software development lifecycle, that will be easier to map your AI model there. Because then if you take just CRISP-DM process, if you map the CRISP-DM process onto the software development lifecycle of your organization, you will have a really easy way to position the checks. Because the checks we define will be then industrialized into your software lifecycle development process, and then it will be easier for having an organization oversight of the organization of your different checks. And that's all from me. Thank you.
If there has been no published rule according to the AI Act, how do we know if what we are creating is actually making the model responsible or not?
Yeah, so the typical answer to that is that so far we have no standard to refer to. And a bit like GDPR actually. So in GDPR, when GDPR was enforced, there was no really methodology defined for validating that your approach was good or not. The point is that in GDPR, the main point was that you had to show that you are willing to do something for going to the direction of the law. And this is what we propose, to do something to the direction of the law. It perhaps not perfect, and by the way, I don't know how to make it more perfect than this, because if you have a quantitative way to measure the risk of your model, by taking different metrics, by looking at different aspects of the risk, I think that you have done at least the maximum you could for implementing the law.
The question that's a bit broad, but can our ethics ever keep up with how rapidly changing AIs are?
Yeah, that's a good point, because that's evolving actually. So if you take back the example, and by the way, even the AI Act, I think, is stuck now with the evolution of the generative AI. That's something that of course we need to look at. So responsible AI, the community is really fast as well actually. So now we have seen, it was a recent publication from Stanford that have a kind of holistic evaluation of generative AI. So they are following up the direction actually. Because why? Because if you take a traditional machine learning model, you have all these different dimensions. So now if you take back a generative AI and LLM and you ask me, okay, can you apply the same matrix to this model? Well, not really, not all of them basically. Why? Because first of all, you don't have access to the training data. You don't know how it has been trained. But everything started from validation. You could apply many different metrics on that. But on top, there is new things that appears. Why? Because normally, most of the traditional machine learning model does not hallucinate. LLM does. So that's something you need to take into account. Most of the machine learning model, when you ask for classification, you don't have the toxicity context. LLM can be toxic in certain contexts. You can have misleading content as well. So all these kind of things should be measured as well. So this is why this kind of publication from Stanford is going to be at least a baseline currently for having a simple way to starting measuring these kind of things. But the community actually is following up. And if we as a company want to offer this kind of services, it's up to us to following up and to be able to provide this update to our customer.
If by any chance the client wants to be at the middle level of a risk, are we willing to be that flexible?
You mean in the risk classification or in the risk scoring?
The risk scoring.
Well, yeah. So that's why it's important for me that you need to have the matrix, the process, and the organization that drive the process. Because this kind of decision, typically, if you want to say that, okay, in our case, there is a category of models that apply directly on my consumer, and there is a kind of middle risk. You know, middle risk is always interesting, by the way, because middle risk means that there is a risk, but I, as an organization, take the accountability to deploy it on production. You know, it's always the same question that we have in privacy. If I anonymize my data, I have a privacy score. I know that the score is not perfect, but I take the risk to go there. And you know, in this kind of context, we always speak about the risk-benefits trade-off. And I think it's a bit the same here. But you need to have an organization there. You need to have bodies, people that are accountable for taking decision there, that says that, okay, now that I know that risk, I want this risk to be, it's at the middle because it should be at the maximum rewards. But I know, knowing the risk, I still decide to deploy it in production. And having that make it much more, let's say, sane. You know, you have risk metrics, you have ability to control it, ability to measure it, and you have people who decide. And I think that's the perfect situation.
Thank
you. Good.
There is no more question, and we can close it.
Perfect. So then, thank you for coming. So if you are there, that shows your high motivation on the topic. So thank you for that. We are going to organize a drink session right now. It's just upstairs here in the cafeteria of Vlerick. So be welcome to have a drink and to still discuss on different various things. Thank you.